The general problem of classical software development always is that usually you have only a vision of the final product when you start the project. People think they have an idea what they want, but basically they only have a vision. So if you ask the business people, they can tell you, yeah, we need a replacement for some software system, but they have an implicit idea what it should do, but maybe this idea is different for everyone. And so you can think of everything that you know typically more like a vision than a clear specification. The requirements are typically incomplete and they change during the project frequently. And the idea of the agile methods, the fundamental original idea was go away from this idea that we can plan things and write a paper before we probably implement something. So the idea is we realize a first product version, which we call a prototype. This first product version is neither complete nor has to be perfect, nor will cover all the requirements right. So it's more like a tentative prototype. And you try to, the idea is now show this prototype to the customer and get feedback on the prototype by the customers, by the users. And the feedback can be either it does not look nice, but it can be, of course, it can pose real requirements. When people see something, they can tell you that it should be different. They might have not been able to formulate that beforehand. But when they see it, you say, okay, this is here. Okay, now it has to be here. Okay, so you get much more precise feedback when the people can see and touch something. And so the prototype helps to collect the information. It either allows to refine the known requirements and also to take into account additional requirements. Because when the people see and use a system, they realize what is missing and what might be wrong. And with that feedback, you go back and implement a second version of the prototype and give it again to the customers, and they test it and you get feedback, and then you continue. So agile methods are characterized by the idea that you have an iterative implementation with refinement of further versions, and that the process model and all this paperwork and these organizational things and management processes are not there to organize a project from the beginning to the end, but to organize only the next iteration. So planning is always related to one iteration. Yes.
What would be the difference between this agile method and genetic programming? When you have a program that people pick up and change?
Yes, the difference is not big. I mean, in agile we do not. Genetic programming is more about automatic changes of code, testing different versions. It's a similar idea. Yeah, it's a similar idea, but in genetic programming, you do it in a way automatic, and in the agile, it's more like doing that with the project team and the customers.
Yeah, but the philosophy.
Yeah, it's an iterative. You iteratively approach to the right. This is why sometimes the agile methods are called evolutionary, like in genetics. It's an evolutionary process. Yeah, sure. Yes.
Where's the success rate bigger in classical development processes or agile processes?
Okay, so all these comparisons are of course a bit ambiguous, but in general, the success rate is usually higher in agile projects, but you might not use the agile projects or agile methods for all kind of projects. So it's difficult to compare. And of course, empirical data is still. There is empirical data, there are studies, but it's not really that you have a hard empirical foundation for. They say, okay, we have so much percentage of success. But in general, yes. So the observation is that agile methods are beneficial for the projects. And of course not in every context and for every problem, but in many contexts at least. And to come back to the question, what is agile? There have been some principles put up by the inventors of these early or these first agile methods like Scrum and XP. So Kent Beck and Ken Schwaber and so on, they sort of, Alistair Cockburn, they together formulated this Agile Manifesto in 2001. It's a web page, you can look that up on the internet. And they formulated some fundamental principles what a good project, a good agile project should follow. So the first principle is rapid continuous delivery of useful software. So the primary measure of progress is useful software, not documents. Because in classical sequential engineering style projects, you can spend a year on documents and everyone puts a lot of effort and you have perfect documents and then the project is cancelled. So you have a lot of nice work and intelligence and effort invested in something and you have no result. Okay, so that is typical for these classical methods because, and this is why the people of the Agile community said, okay, what the customer at the end wants is useful software or useful system or something that does something. Okay, so this should be the primary measure of progress. Customer satisfaction is increased when the people get something to see. They see, okay, there's progress. And working software is a principal measure of progress. Okay. There's this notion of the minimum viable product that should be the outcome of every iteration. And of course, the MVP, the minimum viable product. So the question, of course, is what can be in the MVP? Is it always a complete software, or could it be some prototype done with a click dummy tool or something? It can be different, but at least the customer should get an impression what the system does and if it's right or not. Okay. The regular adaptation to changing circumstances, to changing requirements should be accepted. So even late changes in requirements are welcome. In general, to achieve this, there should be always a close cooperation of business people and developers. So it's not about writing down a specification, throwing it over the fence to some guys somewhere else in the world, in India or elsewhere, and after a year getting back a piece of code. That might be something completely different from what you specified. Okay, so the idea is that the business people and the developers should work together. And this is usually done or encouraged to be done by face-to-face conversation, which leads to co-location. Co-location is the principle that says, okay, the developers should be located close to the business people. In an ideal world, in the same office space. So they can ask directly if something's unclear. And also the business people might give direct feedback. Of course, this is difficult for some reasons sometimes. For example, if you are an external supplier in Germany and you are working on a contract basis for a company, the problem is there's a very useful law that says, okay, if you more or less sit in the same place like the customer and have to say maybe a desk beside the desk of the customer people, and you do that for some time, you have the right to be employed by the customer. And this is so basically that's the outcome of the law. So what is going on is that all the companies like Daimler and so on, they realized, okay, we cannot have the suppliers sitting close to the customer, so we need to have separate spaces. In the beginning, now there was only there was a corridor in between. It should be sufficient, but then of course there were some lawsuits, and then it was decided that a corridor might not be enough. So what happened now is that, for example, Daimler and Stuttgart built some office buildings on their own plant, but one building, the next building, and there all the suppliers sit now. So it's a bit bizarre. This legislation created some bizarre effects. But for example, that of course prohibits co-location partially, and that is a problem. And of course, you have sometimes distributed teams. You have people not only here. You have some developers in India. You have some developers in Japan or wherever in other countries. So you have to find ways to sort of support co-location in a different way, maybe by video conferencing or other kind of remote techniques. One important thing that has been emphasized by Agile also is projects are built around motivated individuals. In the classical project management, you do not talk about people, individual people. You talk about roles. You plan your project and you say, I need 4 junior developers and 2 architects and 1 business analyst and maybe 5 testers and so on. Abstract roles. And with this planning, you presume that these people are identical. every tester is of the same skills as another tester. It doesn't matter who it is. Okay, and that of course is wrong, because you have developers who might be great database developers and others are great in front-end development and so on. So you have different skills, you have different personal preferences, and the people are usually doing the best work when they are doing things that they like. So it is sometimes better to organize a team around their individual skills, and this leads to the self-organizing teams. And the funny thing is, people have always known that. What has happened in the past, or it still happens when you do sequential projects, the customers say, okay, you get the job, but I want to have Mr. XYZ on that project and the other one which I know, and so you have some, the customers start to select the people because they know it's not the same if it's that architect or that architect. Okay, so if they work with you for a longer time, then they realize who are the smart guys, and they always want the smart guys. If you are going to win the project, they of course tell you, okay, but you will win the project, but we need these two guys here. Okay, so the people know that it's not. It matters who is on the project. Okay, and this was realized or emphasized in agile teams. The teams should be self-organizing. The people should select their tasks themselves, so people know best what they can do and what they like, so they do the best work. And to make all that work, of course, the last thing is you need a continuous attention to good technical software design. And the main principle here is simplicity. Okay? Because the problem always is, if you have a big project where everything's planned, if you have a fully specified UML diagrams for everything, it's basically just coding down these things. But if you have changing requirements and very challenging customers, it's always good to have software design that's as simple as possible. You can make easy changes. And this requires that you spend much more effort on quality of code throughout the whole project. Not only test at the end, but testing functionality, but also non-functional requirements and also architectural aspects from the beginning. And this led to the fact that in agile methods, a lot of tools evolved for continuous quality control. Automatic tools like JUnit and user interface tests like Selenium and continuous integration with Maven and all these build things, testing things and so on. So a lot of these tools, and these tools of course they are used in all kinds of projects today, but many of them originate from the agile movement. For example, JUnit was written by Kent Beck, who is the guy who created extreme programming. Okay, so they come originally from extreme programming and have now distributed to other domains. Okay, does this answer a bit what difference in agile from a non-agile method? So as soon as you move away from the idea of document centrification, and you have an iterative method that's not document centric, that focuses on people, that focuses on code.
It's more like a clan or religion.
Yes, it's like exactly, and that's what agile partially is. It's
They choose this name, Agile.
yes, they have the agile movement has sort of semi-religious aspects. Yes, and sometimes it's a bit they tend to overemphasize that. So that I mean, as a scientist, you always should be skeptical. Of course, agile methods have they have some advantages and they are successful, but of course, a lot of marketing has been created around, and this has this aspect of semi-religious things and that is true, and of course you should always be skeptical about everything. So if you ask the agile community, everything's agile. You cannot be not agile. It's strange. So it's not just a solution to a problem, but it has evolved into some holistic thing. And every time that happens, you should be skeptical. But in general, what one has to say that agile methods have advantages in many contexts. They are still not as established as people might think. If you look in the magazines, in the popular IT, in computer science literature, you will see that everything's agile nowadays, but that's not the fact. To my experience, most big companies, at least in Germany, are still doing a lot of things, majority of projects probably in a sequential way. And only the sort of of course the internet business, the web companies, the startups, they have of course more agile processes typically. But if you go to Daimler, to Mercedes, to Deutsche Bank, you will usually have sort of a lot of sequential development with some small agile islands in between. Some projects where they test it, or maybe some bigger projects nowadays, but still there's a lot of classical. And what is very important at the moment, there is this idea of hybrid approaches. They have big projects running sequential, and then they have inside the big projects, they might have some component or some function where they say, okay, let's try agile for that because it's not so critical or something. And then you have to sort of phase that in again. That is very, very current topic in many contexts. So number of agile projects is increasing, but it's not by default everything is agile today.
Could this change? Could this change?
It's slightly changing. So the number of agile projects, it becomes more and more popular at the moment. So over some years, during the last years, in the past, for example, all the companies who are very sort of engineering driven, like car industry or aircraft industry, they of course were, or they still are, very sort of skeptical about agile methods, partially because engineers usually have this classical waterfall way of thinking, but they start to adopt that. When I was working in practice 10 years ago, it was still very, very limited, but nowadays regularly have larger projects running in agile, so it's increasing.
It's dangerous for an engineer design an airplane to just.
Yes, you cannot test that. Exactly. That is the reason why the engineers are skeptical. But nowadays, the first quality assurance control institutions in Germany already certified agile process models for aircraft critical component development. So it is changing. It's not that. Yeah, for software development, for example, for mission critical software in aircraft control. But of course, it's not easy to change that, and it's not changing quickly because you have to sort of test and prove over time that it delivers the same quality. Yeah. And in the internet business, in the web business, if you go to Berlin to a startup, you probably will have everything's lean startup nowadays. Lean startup is nothing but the idea of adapting agile to business development. Okay, so those of you going to Oulu who will live in a startup community, they will probably learn a lot about these things. Okay.
So
yeah,
without there are not much documents in Agile, so with
yeah,
regulations and auditing,
yes,
there must be
documents.
Some
Yeah.
different interests.
Yeah,
So
definitely. And that's an interesting question. Does agile necessarily mean you have no documents? In the past, this was a very frequent thought, or people thought that it leads to chaos and just cowboy coding style. That's not true. I mean, we have techniques to incorporate the production of documentation, which is viable and essential for many organizations, as you say. For example, all the auditors, they want papers. So if you are developing in Deutsche Bank or somewhere else in the aircraft industry, you need to produce paper for certifications, for testing, for auditing. So,
ISOs.
yeah.
ISO.
I-
DIN, some DIN, some
ISO.
Yeah.
ISO, yes, yeah.
Some they need many documents.
Yeah, they need documents, exactly. So for all these quality things, if you want certifications, you need documents. So how can you incorporate production of documents in a sort of an agile way where you are more focusing on the implementation? The idea is, or the concept therefore is the so-called definition of done. For every functionality, every sprint, every task, we will come to that soon, that you do in Agile that has to be done. There's this, you agree in a project on something called the definition of done. What does it mean to have done something? Okay, and the definition of done is a sort of a contract that all the project parties define in the beginning and they sign and say, okay, we agree on that. That has to be done to be finished. And it could be that the definition of done includes completing the functional requirements document. So you say, okay, the functionality is only implemented if it has been documented and updated the functional requirements document. And therefore you can create a documentation But of course, the documentation grows iteratively. So you have the documentation not in the beginning, but only at the end together with the final software. Okay. Okay, some look back on the extreme programming. Extreme programming was the first popular, famous approach. It has been created by Kent Beck and others during a project at Chrysler, where they for the first time sort of collected their best practices that they realized or analyzed in different projects to improve project success. And it is an iterative agile process model which is strongly focusing on programming, and it has been very influential in the beginning. Nowadays people are not talking so much anymore about extreme programming, but it was the original first well-known agile method. Some concepts that are still standard in agile, in any kind of agile methods today, like the user story and the iterations, they were created in extreme programming. The user story is a very fundamental idea of writing down requirements. It is sort of similar to a use case, but less formal and simpler. So it should be readable and writable by end users. And a user story is basically a sentence which is like, as a role, normal user in that case, I can enter something to do something. This is missing here. You could add a reason also to make it more clear. As a normal user, I can enter new customer data to send the customer an email or something. Okay, so this is a user story. It's a simple sentence which describes one task. It's similar to a use case. In a sentence, it gives a reason usually for that task, and it says who is doing that, not the person, but the actor, the role, like in a use case, and what the person wants to do. And if you explain this structure to a customer, usually he will be able to write down some ideas in that type of sentence. The idea is that the ownership of these stories is by the business people. So they have the right to change them, to add news, and so on. So they are more or less describing customer requirements. Of course, this sentence is not complete, and it does not allow to implement that. If you read the sentence now, as a developer, you would say, okay, what is customer data? So there's some information missing. What belongs to the customer data? So what you will do in an agile project is go to the customer who wrote down this story and ask. And ask him, okay, what do you mean by customer data? What belongs to the customer data set? And the customer would say, oh yeah, we need a name, and we need an address, and we need maybe a customer number and telephone number and things like that. Okay? And what you then do is you write down that information. And the original idea of Agile was every user story is written on a paper card. One of these classical file cards, like this size. Could be a bit bigger. And you write the user story sort of as a title on top. And now you can put all the additional information that you collect down below that title on this card. For example, you would write down what you have found out about the customer data. And then, of course, you have to find out what is meant by enter. How do you enter things in the system? Is it a text-based interface, or is it a web interface, or whatever? Okay. So they find out that, and all the information that you collect, you write down on the paper card. And then all these paper cards are put on a board. All the paper cards that are currently worked on are put on a so-called Scrum board or Agile information board or whatever. It's sort of something like that one. Okay, classical pins. You can pin them on that thing. And still, projects use that today because it's very simple and very intuitive and very clear. Of course, there are nowadays solutions to do that in software, in a sort of a web space where you can collaborate also over distances. But
for instance?
GitHub, or you can use their special agile tools like Banana, Scrum, and Agile, and so there are many web-based tools where you have these virtual boards in a way. But still, if you have a project with a smaller team in a company where you have real co-location, they will probably use a physical board because it's very, very nice, intuitive, clear for everyone. You can take a cup of coffee, stand in front, and discuss, and so on. Okay. And during that process, you will refine the information here. The second important concept are the iterations. Every iteration in XP is chosen between 1 and 3 weeks. So the idea is you choose that in the beginning. During a project, the iterations remain of the same length. In general, in all agile methods, you have the idea of a fixed time boxing. Everything is time boxed. You have a certain amount of time for something. For example, every iteration gets 3 weeks, 2 weeks, 1 week, depends. But you have to agree in the beginning. And that means that the customer can be sure that after 3 weeks he will see something. And the developers can be sure that after three weeks they will get feedback and they will get refinement on their user stories. So you have a fixed guarantee that something proceeds and you have progress that you can monitor and that you can control. And during such an iteration, a set of these user stories is implemented. Not all of them, but a set. And this set is selected in the beginning. And during the iteration, the people just work on the user stories. And after the iteration ends, the set of user stories is hopefully implemented. For the implementation, every user story is divided into tasks. And every task is considered to be a few days. And you can assign either one developer to a task or a pair of developers. And the developers should choose their tasks themselves, okay? Because they should be self-organizing. XP is sort of implementing these principles from the Agile Manifesto, like communication, simplicity, feedback, courage. Communication means that it should be always communication. In the beginning, there's something called the planning game, which should be about negotiating which user stories will go to the sprint for implementation. And it will be done together with the customers. We will have stand-up meetings and retrospectives to ensure quality control and learning. And of course, communication also should affect the program code. The program code should be self-explanatory. Simplicity affects the simple design. In general, the complexity should be governed only by the currently required functionality. Don't anticipate functionality that you don't know. Classical programmers always like to do things more generic than necessary because they think, well, if I do it slightly more generic, then we might use it for something else in the future. And they do it more nicely and they add something here and we have a framework here, and this creates overblown architectures, and that should be avoided. Okay. Feedback. Feedback is, of course, customers give feedback after the small iterations, after releases. Pair programming is a way of feedback. Pair programming means that two people work at the same user story or the same task. I will just say a few words on that soon. Then we, of course, have test-driven development, TDD. We will have a look later on that. Continuous integration. All these are concepts that provide feedback either to the developers or to the customer. And courage. Courage is required because a continuous improvement of the technical design requires that you sometimes change existing code. They call it refactoring. Classical developers say, never change a running system. I wrote that, it works, don't touch, let's do something else. And that should not be done in Agile because you want to focus on a good design. Because if you have code that you do not want to change, what you do usually is add something. You build a balcony here, and some additional window here, and something. Touch things on the outside, avoid touching core functionality. And this makes the overall design complicated and error-prone. So design improvement means touch things that are already working. And this is called refactoring. Rewriting the code to achieve a better, simpler design. And this requires courage, because courage, sometimes you are happy if something works and you don't want to touch it, especially if someone else wrote it, so you might not be sure to change it. So to make refactoring safe, or safer, of course, you need support by tools, like, for example, use unit tests that can help you to test immediately if you change something, if it still works in the desired way.
What are unit tests?
Unit tests, we will come back at the end of this lecture. Unit test is a way of automatic testing code functionality. You write a test program that tests. It's usually a JUnit tool. You usually write the test in the same language that you write the application. So it's testing programs by programs. basically.
Yeah, I know.
Yeah, yeah, exactly. NUnit or PHP unit, it exists for all languages today. Okay, pair programming. What is pair programming? Pair programming is probably one of the most discussed and most controversial topics in Agile. Pair programming means two developers work together at one workstation, at one PC, to implement something. Only one of them has the keyboard and is actually coding. It's called the driver. And that's the observer. The other person has the role of the observer. And the task of the other person is to review the code that the other person writes. So you must imagine you sit together in front of your PC, one of you is writing, the other one is always giving feedback. And of course, to make it not too annoying over time, they have to change the role from time to time after some hours. And what is the idea? Of course, the idea is to write better code. Because if two people are doing something, the person who writes has to explain what he or she is doing, and the person who comments has to think about that, maybe give input, feedback. One sort of instantiation of the feedback idea. And of course, the person who looks over the shoulder sees errors, mistakes, can check if everything's right. So the quality of the code is increasing. I think the quality of the code is increasing is undoubtedly the case. The question is more about the effort and the cost. So one of the benefits, of course, is design quality. You have continuous learning and training, so the people learning from each other, of course, getting better ideas, improving their own ideas during the discussion. It increases discipline, because if you sit two persons in front of the screen, you cannot just check your emails in between. Oh, there's something new on Facebook, let's see. You don't do that if you are two persons, okay? Typically. So it increases discipline and therefore productivity. And it helps people getting better developers over time, of course, and it improves the quality of the code. The only problem is it an increase or a reduction of the cost? Because if two persons do the work of one person, traditionally you would only have one developer per task, you can say, okay, it costs you twice as much. But of course there is a reduction again by the benefits that you have. Like the code quality is higher, so you later on spend less money on fixing. The productivity might be higher because the people are not chatting so much on Facebook and reading emails. But and in the long run, of course, you improve the quality also of your developers because they get better developers. They might get more productive in the future. So it's like an invest. So you have some benefits, but of course you have some effort. And the question is it worth the effort? And there have been studies in both directions. There are studies that say, okay, yes, it's beneficial. There are studies that say, no, it's very controversial. The idea comes from XP originally, but is nowadays frequently used. It's used by big companies like Microsoft when they do some core development for operating systems.
It's also for training
yes.
new juniors.
Yes,
and
sure.
Also, when you are in the end of the sprint
Yeah.
and you have like a lazy developer,
Yes, yeah,
you make supervise the node.
yeah, exactly. Yes,
Yes,
Yeah.
I have a question.
Yeah.
Is this kind of pair programming part of a standard process in Agile projects? Because
Not
I know
necessarily, yeah.
an example where there's the one developer is writing the code,
Yeah.
and then another one, after he ended
Yeah.
his writing, has to review the
Yes.
code, and after he reviewed the code and said it's okay, the definition
Yeah.
of done
is completed. Yes. So that's a bit a different approach. It only has the review, but no pair programming, no actual pair programming. So the question was, is pair programming standard? No. Pair programming is an idea that was born together with XP. It was introduced by XP. It has been frequently adopted also by non-agile projects today. But that does not mean that all agile projects are using it. It's sort of it would be a good idea in many projects, but not all agile projects use pair programming. And not all pair programming is not restricted to agile projects. So it's not completely linked with that. But it is sort of inspired by the philosophy of Agile, the concept of feedback, of constant quality assurance, and so on. But it is used in different ways. It is used sometimes in some projects. They use it only for critical components, like an operating system core or something, kernel, like Microsoft is doing to my knowledge at least. And some use it for everything, some don't use it. There's no fixed rule. Some use, like you described, some sort of weakened version where you just have a code review at the end, but not complete pair programming.
Yeah, also in this case that you are developing like a critical module.
Yes.
And you know, like in the agile method, you know that the versions are like a constant.
Yeah.
Not constant. They are variable.
Yeah.
So programmer can let the enterprise. So
Cool.
this one is a new charge.
Yeah. And then you can do it in pair programming to introduce the new stuff.
Yeah.
Yeah. Exactly. Okay. Further questions? Okay, let's go to Scrum, which nowadays is the most well-known agile method. There are some others nowadays, like software Kanban, for example. But Scrum is what is usually, many people think Scrum is a synonym for agile. In many companies, if you say agile, they mean Scrum or vice versa. Scrum is was invented by Ken Schwaber and Mike Beadle, I think in 1994 or something, very long ago. And it's an approach that is an iterative model that basically sort of continues the ideas of XP. It's not completely different. All these agile methods are not like a strict process. It's not like the V model where you have a template and you have to follow the template and everything. The agile methods are more like a concept. You can choose components of it, you can adjust it, and you have to adjust it to tailor it for every company, for every project setting. So the name Scrum originates from the game of rugby, which is very popular in many countries. Unfortunately not in Germany, so here nobody knows that. But in rugby there is this special situation. Last year I was in Australia and had the chance to watch rugby games on TV. So there you could see that they were talking about Scrum very frequently. But it's a special, actually I don't understand the rules completely. People from Argentina probably know them better, I guess, or I don't know.
Yeah, we have one of the
Yeah.
top.
Yeah, Argentina is not so bad in rugby, right?
Yeah,
Yeah, it's good. Yeah. And Scrum is a situation in a game where sort of a number of players are working together, falling on each other or something, I don't know. And can you explain? Do you know what Scrum actually exactly is?
No, it's the moment when all got together
Yeah,
and well, they gather together.
yeah, yeah.
It's like that action.
Yeah.
All gather together.
Mhm.
But you have the ball
In the middle.
in the
Yeah,
middle,
yeah.
and both of them are like competing to.
To get the ball.
Yeah.
Yeah, okay. Okay, so Scrum is not an abbreviation. So it describes more like the situation of it's like a metaphor. Okay, and you have this sports metaphor here. Also, we have this sprint. In Scrum, an iteration is called a sprint, and the original idea was it should be about 2 to 4 weeks, so 1 month or half a month. And you have in the beginning you have the product backlog. The product backlog is a collection of all known user stories. So the customers put their user stories, write them on a piece of paper on the card, as I told you, and put them in the product backlog. So in the original scenario, the product backlog is really a box where you put your cards. Okay. And then for each sprint in the beginning, there's a sprint planning meeting where the customer and the team, the development team, agrees upon and discusses a selection of these user stories from that box that should be done in the sprint, during the sprint. So they select some of them and put them in the so-called sprint backlog, which is the second box, which is what actually should be done in that sprint. And the sprint backlog, for example, could not be necessarily a box, it could be also the board. You could put them on the board, maybe put them all in the left corner, and then always take those that you work on and put them on another place. Okay. And then you have the actual sprint, which is 2 to 4 weeks, a certain amount of time that has been agreed upon before. And at the end of every sprint, there should be a working increment of the product, a minimum viable product, something that you could show and use to the customer. And the working increment always should provide business value. That's also an idea. So the customer should have some function that provides him some usefulness. It's not just, okay, I have done the login and log off function. That's not no business value. Okay, it should do something. And yeah, that's an important idea. And during the sprint, the team only works on the sprint backlog. So they take these user stories and try to implement them, go to the customer, ask for more information about the details, and implement it. Okay. And then, of course, there's a second iteration, the daily iteration. Every 24 hours in the original idea, it could be less, it could be more, of course, but in the original idea, you have the Scrum meeting. The Scrum meeting is sort of a daily checkpoint where you check in the team what was the progress and what are the impediments for the next day or for the future. Okay. The Scrum meeting is very famous. It is, in the original literature, it says it should be organized as a stand-up meeting, which means that all the participants should stand. Why should people stand? Because when the people stay, they don't stand. They tend not to talk so long. When they can sit, it's more convenient. So standing around the table makes meetings shorter. That's one reason. It should be at the same time, the same location every day, and it should be precisely on the same time. Why? Because typical situation in the classical projects is, okay, we need a meeting tomorrow. Oh, I don't have time, I have to fix something. So you organize a meeting, half of the people is not coming because they have something more urgent to do. And then, of course, a few people sit around and start talking about some particular problems of them. The others sit around and have to say nothing, so the meeting is very inefficient. Everyone knows that. And to avoid this inefficiency of meetings, the Scrum meeting was designed in this way. Standing participants fixed precisely on time, because if you have it at the same point in time every day, and it is short, the people have no excuse. They can just say, okay, tomorrow at 3 o'clock I can't come, but 15 minutes later it's fine. So it's usually not a problem if you know when it is and it's short. So it's at the same location and time every day. It has a fixed duration, 15 minutes approximately, and all attendees should stand. And all participants are welcome, so management can come and take part, but they should not speak. Only the so-called pigs can speak. I come back what pigs are. And during the Scrum meeting, the so-called Scrum Master asked every team member 3 questions, one after another. What have you done since yesterday? What will you do by tomorrow? And are there any impediments prohibit you from doing that? Basically, this is sort of a quality meeting. So the Scrum meeting is a checkpoint. It's a status meeting. It's not a meeting for solving problems. Solving problems is done afterwards, separately, in a bilateral way. Okay. So what are pigs and what are the roles in Scrum in general? So Scrum distinguishes between 2 roles of people, the pigs and the chickens. The pigs are committed and the chickens are involved. So the pigs form the actual core team, whereas the chickens are all the others around, users, managers, and things like that. This comes from a joke which goes like this. A chicken and a pig are walking down the street. The chicken asks the pig, "Oh, why don't we open a restaurant?" And the pig answers, "How should we call it?" And the chicken says, "What about ham and eggs?" And the pig says, "Oh, that's not a good idea. I would be committed, but you would only be involved." Okay? So that's the reason for that. So the pigs are the people who are committed. This is the so-called product owner. The product owner is a representative of the customer to the team. You can think of the product owner as sort of the project main sponsor, the person in the business department who wants the project. Classical, it would be the business side project manager. Something like that. He's the voice of the customers, and he's responsible for writing or collecting at least the user stories and deciding which user stories should be put in the product backlog. Of course, there are the customers and the users who can put input to him, but he or she has to decide whether this is finally to be put in the product backlog or not. And then there's a Scrum Master. The Scrum Master is basically sort of a team manager, but he's not, or she's not sort of the head of these developers, but it's more like so they call it a servant master. The task is to ensure the ability of the team to deliver the sprint goal. This means to ensure that the Scrum process is used as intended. To check and ensure all these rules are kept, and documentation is done, and the definition of done is done, and so on. But he's not the leader of the team. The team should be self-organizing. So the Scrum Master is not telling the people what they should do. She's just checking and controlling, and also on the other hand serving the team in a way to solve issues with the customer, move away impediments, get the right information, get contacts to people who are missing, delivering missing information. If you are in a big organization, typically, sometimes the problem is in the beginning is to get the information, to at least find the person who can give you the information. And these are our tasks that the Scrum Master needs to do. And then, of course, you have the development team, which consists of all the people who are contributing to the development, the designers, the developers, the testers, and so on. And then, of course, we have the chickens. And these are all other people, stakeholders of the system, like auditors, managers, users, and so on. And it is important that in the Scrum meeting, these people here are not discussing, because typical situation is you have a meeting, all the people are discussing a problem, top-level manager comes in and says, oh, well, what are you talking about? And then, oh, we have to do it completely different. I talked to the CEO yesterday, and the strategy has changed, and so you blow up the meeting. And to avoid this situation, these people are not allowed to speak during the sprint. If they have some changes are welcome. They will be done after the sprint. So for the next sprint, goals might change. Okay. So the important thing is what means a working increment. The original definition was a potentially shippable software, which is already a rather high requirement, because it needs to be that the software is working, that it can be used, and so on. Of course, this has been sort of weakened up over time. Nowadays, a potentially shippable product might be also very often a UI prototype, click system, and it just can click to test functionality, like you can create with some prototyping tools without programming, things like that. In general, to check what it means is to define the definition of done. The definition of done can be defined on any level. It can be defined for every sprint. So if you look here, you can have a definition of done for a sprint, for the increment, for every user story. So on different levels, there can be a definition of done. The definition of done is basically a checklist describing all activities that add verifiable or demonstrable value to the product and are required before something is considered done. So it can be defined on different levels. They should be defined by the team and the product owner in the beginning to agree upon. And they can cover user stories, tasks, and everything. And this is the way how you enforce proper documentation. If you need documents, like for auditors, it should be done using the definition of done. Important.